All right, guys, so here we are. We're going to do the conservation of mass lab. So for this lab, the idea is to show you that the mass before a reaction occurs is equal to the mass after a reaction occurs. So to do this, we are going to actually observe a number of chemical reactions occurring within a closed system. We're going to do that simply by having a big test tube filled with one solution. We're going to stick a smaller test tube inside of it with another solution so that the two don't mix. And then we're going to be stoppering them, therefore creating a closed system, weighing it, mixing them, and then weighing it again. And the idea is that you should see that there is no actual change in mass. So to do this, we are going to start with getting a copper solution here. We're going to put that in the small test tube. I'll try to get a half decent amount here. So the first thing you want to do on your observation chart, I'm just going to move this off to the side a bit. Come on. And here's your observation chart. So you're going to want to record your reagent A is going to be copper 2 sulfate. Reagent B is ammonium hydroxide. Okay. You are going to take observations of it. So this is your copper 2 sulfate. You'll notice it's kind of a thin blue liquid. Not much more to be said further than that. And then you've got your ammonium hydroxide. I'm going to put that in the big test tube. So here you should have here you've got your ammonium hydroxide. Some people say it's a bit pink in color. I don't honestly see it, but I am colorblind, so it's hard to say. But it's a thin liquid, kind of like water, pretty indistinguishable from water. You can take a smell of it. It does smell just a little bit of ammonia, but not really too much. Neither of these liquids really have much of a smell. So then what you're going to do is you're going to take your two test tubes, you're going to put one inside the other, and you are going to gently, ever so gently, put one inside the other, hopefully so it doesn't make a mess, and you don't mix them yet. And then we're going to stopper it. So there you have the two solutions in there without mixing. You are going to weigh them, and we've got 49.4. So this is my second time filming, so you're going to write in this blank here, before mixing, 49.4 grams. Okay. Make sure that you've recorded your observations here on the reagents. Okay. Once you have the weight in your observations of these two solutions, you are then going to invert this so that you can get a reaction. So you're going to invert it like so, and you will see it turns cloudy. So why does it turn cloudy? That is because you are actually forming a precipitate in there. I wonder if I can get that closer. It's hard to see, but there's a precipitate forming in there. So it's no longer perfectly clear. You can't see as well behind it. That's because a precipitate is formed in there. So you should be taking observations there in this column of your observation table on what this looks like. Okay. We're also going to put it in here, and we are going to weigh it, and you should notice that it is 49.4. So that is the first reaction. Okay, so here we are ready for our next one. So this right here is our potassium iodide. So you're going to want to write down potassium iodide right here. Potassium iodide, and then our other solution that we have is silver nitrate. You're going to want to take observations on this. So potassium iodide looks like this. It's a fairly clear liquid. Honestly, I can't tell the difference between it and water. So thin. Do a bit of wafting here. Doesn't have any smell to it that I can notice. We also have our second reagent here, which is silver chloride, or sorry, in this case, silver nitrate. So you got silver nitrate here, that's this one. You will notice, ignoring the stains on the test tube from some iodine, obviously. You can't really tell on the camera, but it does have just a little bit of grayness to the solution. So it's not perfectly clear, but that's mostly due to undissolved silver nitrate in there. Okay. When it's totally dissolved, it is clear, just like water for the most part. Okay. So what we're going to do, we are going to take our potassium iodide and our silver nitrate. We're going to slide that in there, and we are going to try not to make a mess of it. So we're going to do it as gently as possible. There we go. We're going to stopper this, and then we are going to weigh it. So we're going to turn this on, let it zero, and we're going to check out how heavy it is. So we're going to weigh it. It is 48.4. Okay. Remembering that you should have written down here your observations. You can write your 48.4 grams. Okay. Then we're going to take this. You are simply going to invert it and check out that reaction. There's a very clear reaction going on there. So what you'll be noticing there, that is also a precipitate forming. So you take your observations on that solution right there. You should be writing your observations down in this box right here on your chart. Okay? And while you do that, I am going to set up for the next one. Sorry, correction. Before I set up for the next one, I forgot to actually reweigh it. Did I? Either way, 48.4. You'll want to write that second weigh, 48.4, right in there. Okay? Okay, this next reaction is kind of a fun one. So, zero our balance. Coming back to our chart, we are going to be mixing iron 3 sulfate. So you can write iron 3 sulfate. And the other one is sodium hydroxide. Sodium hydroxide right there. Okay. So our iron 3 sulfate looks like this. This is our iron 3 sulfate. It is a thin liquid, with a yellowish tint to it. Okay. And here is our hydroxide. It should be clear, just like water. Ignore the stains on the test tube. It is clear, thin, liquid, just like water. Okay. So what we're going to do, so you should write down your observations in there. Okay, just like before. We are going to slip this one inside of there without them mixing. We're going to put our cork on there, stopper, and then make sure this says 0, 0, and we are going to weigh it. And we get 49.5. So make sure you write down your 49.5. And then when it comes time to mix, so we're going to take that, we're going to invert it. And there you go. So you take your observations of that liquid to give you an idea of how see-through it is. So it has gone kind of cloudy. The longer you leave it, the more, I guess, chunky it goes. So you should be reporting your observations of this solution in this last column of your chart. Okay. We should also weigh it again. So you still have 49.5. So sometimes if you're really close to the in-between, so this is actually probably pretty close to like 49.45, that is the time when it will start switching back and forth. So you might have noticed this at 49.4 the first time I did it, like there, 49.4. That will have to do mostly with small error in the scale, or being really close to the in-between weight. But 49.5, we had it there. Right there, 49.5. So there is some error in these scales to be expected. So that is our last reaction. So now what you should be doing is completing, there is a discussion for this lab available online where you will be completing a balanced equation for these three reactions, right?